The Doppler effect is the apparent change in the frequency of a wave caused by the relative motion between the source of the wave and the observer. As seen in this picture, when a wave is moving towards an observer, the wave is perceived at a higher frequency, but when a wave is moving away from an observer, the wave is perceived at a lower frequency. Pitch corresponds to frequency. A high-pitch sound corresponds to a high-frequency sound wave, and a low-pitch sound corresponds to a low-frequency sound wave. Let's take a look at this in a demonstration. As we can see in this demonstration, as the car approaches a stationary observer, the sound waves are perceived at a higher frequency and therefore a higher pitch. However, as the car passes the stationary observer, the sound waves are perceived at a lower frequency and therefore a lower pitch. Yet we must remember that this change in frequency and pitch is only perceived by the stationary observer because of the movement of the source emitting the wave, which in this case is the car. To the person driving the car, the frequency and pitch of the car horn remains constant because they are moving along with the car. It must be noted that the Doppler effect only occurs for the stationary observer because they perceive the change in frequency and pitch of the sound waves due to the motion of the source emitting the waves, which is the car, relative to them. This demonstration shows a car moving towards an observer. As the sound waves from the car horn approaches the observer, the crests of the sound waves move closer together, decreasing the wavelength of the sound wave. If the sound wave has a shorter wavelength, that means the wave also has a higher frequency, due to the inverse relationship between wavelength and frequency. So we see that as the car approaches the observer with a higher frequency, the observer will also perceive the sound wave to have a higher pitch. Let's take a look at what this would sound like in real life, first from the perspective of a stationary observer, and then from the perspective of someone driving the car. So why is the Doppler effect important? This phenomenon is extremely important because it is a major piece of evidence for how we know that the universe is constantly expanding. Let's talk about redshift. Redshift and blueshift describe how light shifts towards shorter or longer wavelengths as objects in space move either closer or farther away from us. When an object moves away from us, the light is shifted to the red end of the spectrum as the wavelength increases and the frequency decreases. If an object moves closer, the light moves to the blue end of the spectrum as its wavelength decreases and frequency increases. Redshift is a key concept that helps us understand the expansion of the universe. Universes are constantly expanding and moving away from one another, proven by the redshift of light on the electromagnetic spectrum. The Doppler effect and redshift prove that at the end of this video, the universe has already expanded and grown larger than it was just minutes ago.